video, we're going to do parallel circuit calculations for resistance, current, and voltage. Excuse me. So, resistance, current, and voltage for a parallel circuit is different than a series circuit in that, one, a series circuit follows a singular path. And here, we actually have multiple paths. So that's one path. Here's another path for the current to flow. And finally, we have a third path as well. So initially, there's one distinct difference in that a parallel circuit will actually have multiple paths of flow, whereas a series circuit only has one. And in addition to that, the equations are different. So we have 1 over RT. So for resistance, we're actually not going to calculate resistance by just adding them up. Here, the resistance is actually the reciprocal, or the inverse, or the flipped fraction of what we saw in the series circuit. So 1 over RT, or resistance total, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Let me actually specify that over here, R1, R2, R3. To go a little bit further, the current for each one is equal to the sum of all the currents. So for each one of these paths, how it works is, just think of it like this. The current is your attention span. And as your attention span goes to one task, you have the full attention span. And that's what a series circuit is like. You're doing a singular task, and all of your attention is for that one task. But here, you have one item on your to-do list that you're doing, but at the same time, you're doing another item in addition to another item. So you're multitasking, and you're doing all three at once, but your attention span can't be fully present in each one of these. So just think of it as the same here. The current, they're going through all the paths at the same time, but unlike a series circuit, there's multiple paths. So that means that your current is split. But on the other hand, because they're going through all of it at the same time, the voltage is the same throughout. And this rule would generally, or all these rules would just get you through how to solve each one of these for a parallel circuit. So let's dive a little further. Let's go ahead and draw our box like we did last time. And I recommend doing this for every problem that you get regarding this. It will help you keep your work organized, and in my class, I would actually expect that these boxes are drawn just for the practice and the organization. And in addition to these, we have our own individual components, R1, R2, R3. Okay, so I'm going to go ahead and fill in what I know. So the voltages are the same throughout the entire thing. So that's an easy one to know because it's the same, and I have a 45-volt battery right here. I'm actually going to fill that in with the 45 throughout it. Now, to go a little bit further, I have another thing that I can calculate. All of the resistances are given to me. So all I have to do is put it as 1 divided by whatever resistance I'm given. So if I were to give an example, if R1 is equal to 10 ohms, when I'm calculating my resistance total, what I'm actually going to do is 1 over RT is equal to 1 over 10 ohms plus 1 over 12 ohms plus 1 over 14 ohms. And that would get me 1 over RT. But in order to flip that around, so let me go ahead and calculate this. And I'm not looking for 1 over RT, I'm looking for RT. So I want somehow for this to become just RT. So let me go ahead and calculate all of this. And I get 1 over RT is equal to 0.254 ohms. And typically when I like to do for these problems is, for those of you who are not fully familiar with the calculator, always convert this to a decimal first. Like 1 over 10 is 0.1 plus 1 over 12 is equal to, sorry, let me go my units, ohms, 0.083 ohms, and you add that with 1 over 14, which is 0.0714 ohms. So always convert it to a decimal if you're not fully comfortable with adding fractions directly on the calculator. Now, to get this to just RT, so right now it's 1 over RT, right? We want to get that to just RT. So I would actually have to do the inverse of that, or essentially the reciprocal of that. And what I do to one side, I have to do it to another. So if I were to find the reciprocal of 0.254, my reciprocal of 0.254 is actually 3.93 ohms. So that's what my resistance total would be. So 3.93 ohms. Now my resistance 1 is 10 ohms. I can go ahead and fill these in. 12 ohms and 14 ohms. So all of that right there is my resistances as well as my resistance total. Now to find current, I essentially just have to do the same thing with V is equal to IR. So VIR, and I'm trying to look for current, so I like to cover it with a highlighter. So let's say I cover it, and I see that to find current, what I have to do is divide voltage by resistance. So I do that for each one of these. So I go ahead and I take voltage, which is 45, and I divide that by my resistance, which is 3.93, and I get 11.45 amps. So let me go ahead and do that with the second one, which is R1 and V1. So let's say I take the voltage, which is 45 volts, and I divide that by 10 ohms, which is equal to my current. And when I really just plug that in, I get 4.5 amps. And I'm going to go ahead and do that same exact step for each one of these. And I get my total essentially. So I successfully just solved out the entire parallel circuit. And it's a very simple process if you just use this box. So use this box method as well as the equations, and the equations right here, as well as the magical triangle right there, and you should be able to get current, resistance, voltage very easily.